Okay, so as we said, welcome everybody. We will talk a bit mostly about open access, but also about open science, responsible research and innovation, and Horizon 2020 in Europe projects, because it's the broader context where also open access is taking place, at least in European projects, also in the projects where we are, but it's also a good context for seeing how open access can be done in practice. So we'll be covering with both theoretical parts, but also in practice how to do that. First, a bit of introduction. First of all, from MIT University, we always start any public event and so on with acknowledgement of country in terms to show respect for Australian indigenous cultures. Basically, the message we always start with is that RMIT University acknowledges the people of the Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nation, of those unceded lands we conduct the business of the university. RMIT University respectively acknowledges their ancestors and elders, past and present. RMIT also acknowledges the traditional custodians and their ancestors of the lands and waters across Australia where we conduct our business. And a brief introduction of myself. I'm a research fellow at RMIT University, here based in RMIT Europe in Barcelona. Mostly working on opening a train project. I will introduce a bit afterwards. At the same time this year, I'm also senior resident researcher at Politecnico di Milano in the School of Design. And my background is actually in new media and design. I studied in Aalto University, my doctorate in industrial design in Politecnico di Milano. It's already more than, I think, 6 years working on new projects and more than 6 years in research and practice. So this is also based on those years of experience a bit. So this lecture, it's a part of 2 projects. We are making a joint event, 2 Marie Curie projects. The first one is Opening No Train. Opening No Train is a Horizon 2020 Marie Curie RISE action. It's a global network of researchers and industry practitioners across Europe and Australia that work for promoting the translation of research between university industry to cooperation and with an open innovation. This works in the 4 sectors from FinTech, Industry 4.0, Cleantech, and Foodtech. And we have more than 20 partners between academic partners in Europe and industry in Europe, and also RMIT in Melbourne. So from from Finland, Norway, Portugal to Spain, Italy, and Melbourne. It's a RISE, which is Research and Innovation Staff Exchange program, which means the focus here, as on the Marie action, is on promoting the career of researchers or staff related to research and innovation. Here, especially through mobility, through secondments, so the staff exchange. And see, for example, we have already several secondists that changes. For example, Victoria Drave, that from THH in Hamburg, spent more or less a couple of months in Melbourne. Ebo Uraful from Vasa, and spent a month or a bit more in Melbourne. Green Rablane, that from Vasa as well, spent more or less in a couple of months in Melbourne as well. But for example, we have also Zoran Krupa, professor in University of Zagreb, that spent time here in Barcelona, a month, just to give you some ideas. Well, then, as you probably already know, the other European projects that, let's say, we publish this event is Einstein. Here, the Marie Curie action is an innovative training network, ITN. So it's not mainly on secondments, but with doctoral networks also, even if you also probably will be doing some secondments inside this. So you will also have an experience of what a secondment is and can be. And in this case, well, you have mostly beneficiaries and then partners and later for secondments. So slightly bit different format in terms of action, but with some similar approaches in how to promote careers of research staff. In this case, this connection in digital transformation, Industry 4.0. So let's start with the content. What is open access? So as a first step, normally if you don't know what is really open access or you've never seen it, something you will find when you see at least some academic articles, because you see this orange label open access with the open log, or sometimes you see it as an article as a Creative Commons license added to it. These are the easiest way to understand if an article is open access, but it's also probably the first experience that of what is open access you will find. You will see if an article has these two elements, normally it's an indicator of this open access. So what is open access? Besides just some additional elements, additional metadata to an article. So it's not just a single article. It's already a very broad ecosystem. First is there are several journals that have open access articles. So for example, you can find and look for them here in this directory of open access journals. So you see there are more than 11,000 journals without APCs, and we see what APCs are a bit later, and already more than 5 million article records. So let's start for formal definition of what is open access before seeing a bit more the other things. And there are two definitions that were done almost 20 years ago. The first is the Budapest Definition. It's a long definition, but this is the closest thing to a short definition from that. By open access to and literature, we mean that it's freely availability on the public internet, permitting any users to read, download, copy, distribute, print, search, or link to the full text of these articles, crawl them for indexing, pass them as data to software, or use them for any other lawful purpose without financial, legal, or technical barriers other than those inseparable from gaining access to the internet itself. The only constraint on reproduction and distribution, and the only role for copyright in this domain, should be to give authors control over the integrity of their work and the right to be properly acknowledged and cited. So this is quite broad, but it's really about what is really open access. It's not just putting information online, but let it accessible for doing all the different kind of action that we will need for doing research, which is most of the time will be probably just to download and read it, but it's also getting access to the data, added to software, indexing, adding to research engine, do more analysis. And the fact that this access should be as open as possible, being that, of course, beside the technical limitation of accessing, there shouldn't be other artificial barrier added. Okay. The important thing that the role of the author is always considerate, it's always important. It's just that, of course, this is mainly something that serves for protect the integrity of the work and the author, not for stopping the distribution of the content itself. A following definition is the Berlin definition that was done the year later in 2003. It's a bit, again, a long document, but I'm taking a bit of the most relevant parts. And you see, again, this is something that we should consider in very broad terms before going to very specific in terms of article or dataset. Open access is a comprehensive source of human knowledge and cultural heritage that has been approved by the scientific community. In order to realize the vision of a global and accessible representation of knowledge, the future web has to be sustainable, interactive, and transparent. Contents of the tools must be openly accessible and compatible. So again, it's not just about being able to download an article, but it's a vision for how knowledge is shared and also how the internet will be developed. So this was on 20 years ago, almost 20 years ago, but that shaped a lot of actions afterwards. So things are now more taken for granted. 20 years ago, they were not as much. And I know because I've been also working on this and the Creative Commons for some 16 years. What the Berlin definition says about open access, first, there are two conditions. So the authors and right holders of such contributions grants to all users a free, irrevocable, worldwide right of access to and the license to copy, use, distribute, transmit, and display the work publicly, and to make and distribute derivative works. in any digital medium for any responsible purpose, subject to the proper attribution of authorship. Community standards will continue to provide the mechanism for enforcing proper attribution and responsible use of the publisher's work as they do now, as well as the right to make small numbers of printed copy for the personal use. I'm reading this just to be very precise with it. If you have any question, let me know. It seems quite clear to me. I don't think that there should be more explanation on top of that. Another thing to be considered that basically this is another element. A complete version of the work and all supplemental materials, include a copy of the permission as stated above, in appropriate standard electronic format is deposited and thus published in at least one online repository using suitable technical standards, such as the Open Archive definition, that is supported and maintained by an academic institution, scholarly society, government agency, or the well-established organization that seeks to enable open access, unrestricted distribution, interoperability, and long-term archiving. But this is something that probably we should explain a bit more. Basically, this content, whether it's an article, a paper, a PowerPoint presentation, a dataset, together with the licensing terms of how basically the item is shared, should always be stored somewhere online, which is accessible and typically in some online repository, whether it's done by university. Normally, each university has their own repository for tracking not just the production, but also giving access to, or general repositories. We will see some of them later, for example, like Zenodo, or other kind of repository. Also the Open Archive, yes, it's another website that's for not just a scholarly article, but in general content. And this for making sure that then the documents are always available. It's not just that we put on a website now, and it's a small website, and in a few years it's gone. So there are several types of open access. These especially related to articles, to journal articles or conference articles. Open access to datasets can be a bit different. And this is actually a way that is quite simple for everybody to understand the way the open access is done, because there is a color naming system for that. So, and this goes, let's say, from the best one, the diamond / platinum, to the not really the best one, to the black open access. I mean, this sort of also classification, no? Because what it says, basically, diamond, platinum open access is basically, it's not just the article, it's article and also the journal, but normally it's basically the journal which publish open access without charging articles any money, any fee. Okay, so you submit an article to a journal, you don't have to pay anything, and once it's ready, it will be directly open access. There are costs involved, of course, on running, managing a journal, reviewing this. This is also a very big topic, so we'll not go so much into detail. The important thing is that when you find this kind of journals, like there is no funding required for publishing for you as authors. Okay. Then we have the gold open access. Okay. So the publisher makes sure that the articles are open access, but basically, instead of putting a price on the article for your users to pay in order to download them, you as an author, I mean, you, of course, you or the university for you, together with you, any funding agency will pay for that. Okay, so for the user in the open access, the difference is that the author has to provide the funding for this. The green open access basically says normally all publishers in different ways, but they enable always the authors to do a self-archiving of the work. So basically you can store a draft of your work online. Normally there are repository only for preprint draft, like archive.org, or also in the university. And so this is what is called green open access. So normally you should check with each journal, which is publisher, the way they would like to do the green open access, because there is not a standard way for doing that. And so it depends on what they permit you. Sometimes they let you submit online the first version that you submit to the journal. Sometimes it's the last version, or it's a version after the review. So it really depends on the journal itself. But this is something that is very important, especially in European projects. So if you can go for the diamond and platinum or gold, this is also an important option to check. So always when you decide where to publish, check if the green open access is permitted. Most of the time it's permitted, but you're not really sure unless you check. The hybrid open access means that in the same journal you can find a mix of open access articles and closed one. Okay, so you're not really sure by judging by just the one single article if the full journal is open access. You need to check a bit more into details. The bronze open access. So this is a tiny bit difference. We'll see in detail later, but it's not very tiny. It's just for reading. Sometimes the article can be downloaded, but that doesn't mean that you can redistribute the article, that you can reuse. It's easy because you don't have to pay money for reading it, but you're not really sure you can build work upon that. And that's an important part of open access. You know, again, it's not just, oh, I'm gonna use this for free. I'm gonna download this for free is basically what you could find in the black open access. And basically it's unauthorized digital copying at large scale, so it's not just one article, and storing basically copies with copyright infringement and giving access to lectures to this being paywall. Okay, so there are famous website that does that. There are individuals also that did that, and this is not authorized, so this is illegal, so that's why it's black. And what you can see as a final end user is like, okay, you're reading something for free. It's just the black basically something that is being pirated, and the bronze is just you can read it, but you cannot do anything else beside that. Anything else means that if it's not clear for no specific license, you cannot even send an email to somebody with a file, because that will be an infringement. It has to be full open access to be that, and we will see then later. Again, so since we started also with the issues of funding and money, and I'm also putting this because it's always one of the most important questions people ask. So the funding for this. Sometimes, so when the journals ask for a fee, these fees are called article processing charges, or RPC. Basically, it's literally like the funding, the fee that is necessary, the money for the journal for manage the article and publish it. Okay. Some journals also print copies. It's not completely digital, so they also have funding for that. Some other journals, they have other costs. So it's not necessarily for free. Again, this is a very big and debated topic. It's just to, of course, to remind that it's not completely free. So that's why sometimes we have these fees. Again, this may be paid by an author, by the author's institution, or the research funder. Okay, then this could be a single author or the university if has something allocated to that, or also the research funder, meaning, for example, a European project might be the commission, of course, within the dynamics of the project. I'm showing that sometimes, for example, you can see the link, then you will see also the links when you will download the presentation at the end. And you can also see how these costs are distributed, you know, and how the money is used and why there is money for needed for this. So it's good at least to understand how the business of publishing scholarly articles works. How much money do we have to pay? Well, it depends on the journal. So sometimes you have that a single publisher will provide you an Excel with all the journals, or a search engine where you just put the name of the journal and it will tell you how much the cost is. Sometimes they tailor the cost based on the country where you live. Sometimes not. So if you see, for example, in this case, you see also what is the type of journal, if it's open access or hybrid, and what you will pay in dollar, euros, pound, and yen. So the price actually can range from as little as $250 to more than $3,000. This more or less was plotted some years ago. So you see, well, there is a peak 250 and 2,000. through a lot. I've actually probably seen myself more journals ranging in the 2000 to up, but depends on what you find. It could be on different part of this range. And the problem, of course, is that the prices could be up. This is also a bit old because I don't know if then Nature is going forward with that, but they, last year they announced that they were about to go to 9,000. Like, you really want to be on Nature, you're going to pay $9,000 or something for that. You understand that this can be up to like a price that a single author can really afford. Doesn't make any sense at all. So that's why this is also critically debated topic. Okay, we don't have a solution yet, but just want to show you because it's important to understand the mechanism. We actually start to have more solutions. In any case, the platinum, diamond journal are still available. Probably less, but always have a look for them. So let's go a bit deep into the licensing part of that, the copyright part. You know, so at least for understanding why this is not only about I download the article and read it for free, and it's more about creating an ecosystem for sharing knowledge and using knowledge for building further knowledge and advancing knowledge. And normally, copyright is actually a mix of two types of rights. It's not just copyright. And these two categories are economic rights and moral rights. Okay, economic rights is really like the copyright, the right to copy and distribute and basically make money out of any type of work. Okay, so it's reproduction, distribution, performance. Another important thing before that, we're talking all about copyright today, but there are other kind of items in the world that are not covered by copyright. Like copyright normally covers any kind of creative or scientific one. But for example, if you have a technology, a mechanism or process that's normally are patented, the patenting system has completely another way of working because it's basically, it's like if the artifacts themselves are considered as different kind of entities. It's like if you compare a human person and an animal or a rock. You know, the rock cannot be considered in terms of where are the organs of the rock. No, the rock doesn't have any organs, so we have a different way for dealing with it. So in terms of copyright, beside economic rights, which is again the right of copy, is the moral rights. And this is basically the right of you as authors to always be considered as the author of that artwork or that artifact or that piece of knowledge. Okay? So this is important that basically the author can always claim the authorship of a work, saying, I did this. And also whether you want to have people to modify that, to change it, to build on top of that. Okay, this is more about the integrity of the work and the authorship. The other one is about distributing and making money of it. Okay, no, so it's not just about copyright, it's copy and author rights together. Okay, these are simple things, but actually important for understanding this. And why this is important? Because especially this is a thing of open access, takes place with Creative Commons licenses, and they really work on top of this distinction. So again, Creative Commons is an initiative that is now 20 years old and created a lot of work on legal terms, but also in terms of tools, of events and community, for making this possible, making open access possible and not just promoting it. So what do the Creative Commons licenses do is basically they work on this distinction between the moral rights and the economic rights. Okay, so the important thing is basically you as author with Creative Commons, you always keep the moral rights. What you're waiving are the economic rights. So you are always the author. Okay, you always be cited as the author. You're just enabling people to distribute the copy in a different way or modify the copy in a different way. Okay, if I download an article with copyright because they let me download that, I cannot send it to you because I don't have the right for reproduction and distribution. I cannot even change it. I don't have the right. But with the Creative Commons, I can do that. So, and these in Creative Commons take place with a different set of licenses. Now we are at version 4.0, and things change through the year. There are some elements that were changed a bit. So normally in Creative Commons license, you will have, well, the long term for the license. Then you have the short way of calling it. For example, CC as Creative Commons and BY. And then sometimes you have these icons, so it's easy for you also to see just from the icon what it's about. Okay, so the simplest one is the CC BY. BY means that basically it's always required the attribution of authorship. So anything that you find that has this license basically can be distributed, remixed, adapted, and built upon. But as long as whoever does that, always credit the original authors as the original authors. Okay, so this also allows for commercial use, for example. This is the basic one. The BY attribution element is always present also in the other licenses. You cannot escape that. This is the moral rights. So with this, you make sure that the authorship is always credited. Okay, so if you have an article with that and somebody download and then change the name without crediting you, you can sue them. So the next step is the BY share alike. So it's like the BY. What does the share alike means? As basically any type of work that is built on top of the previous one must always have the same license. Okay, so you restrain people to just use the same license. And why this is important? Well, because there are several options of licensing, and you want to make sure that people always keep this as open as possible. The BY is also the most open as possible license. Then you have the BY non-commercial. Again, the BY is always present. Non-commercial means that you can redistribute the content, but no commercial activity can be done on top of that. You cannot sell it. Okay, you cannot send the architect. This sometimes is also not considered open access. This is very important. Normally, open access is basically only CC BY, and sometimes it's called like non-open or other kind of access licensing, but it's a possibility. And then you can also have the non-commercial share alike. So again, you want to stop that the further version of your work has some different kind of licenses. This is if you are normally the share alike if you want to be very precise about how the licensing of the work, because it makes some specific sense and you want to be sure that it's not changed after. Another kind of not really open Creative Commons license is DND. DND means not derivative, meaning that you don't want any other person to build work on top of that is different, that is modified or is adapted from that. So why this is not open? Because you realize that it's basically this is people to distribute the copy, but not to build anything on top of that in terms of research and further work. It's basically an immutable piece of knowledge. Sometimes you find the BY and C and D, attribution, non-commercial, no derivatives. So basically, there is always attribution, but then nobody can make money out of that, and nobody can change that. So this is the less close Creative Commons, because this is the closest thing basically to a copyright that you can actually at least distribute. So you can still send it around, but it's not really open. Then on the complete opposite, okay, there is something else that is the CC0, and this is a concern with the public domain. So normally, because in each country things are a bit different, how does the copyright works? You know, from the moment of creation, or let's say the moment is certified or is documented mostly that you create something, you already have the copyright. If I write a songs about a dog and you write a songs about a dog, we all have our own copyrights. I have my copyrights of that song, you have the copyright if the topic is the same. So imagine how many songs about love there are out there. And then normally what these copyright companies, or how you call them, you know, they basically have a database of all the songs, of all the books. So basically you're sure that this is properly documented, you know, in terms there is some discussion drives. And normally this is copyright, until after some, now I think it's 75 years after the death of the author. Means that now if you go and look for books by authors that died 70 years ago, you can download them for free. Okay, so after that, work goes into the public domain. A similar mechanism with the patenting, and normally in patenting is like 20 years. After 20 years from the patent, then the patent is public domain. Public domain means that anybody can take that information and build on that. They don't have necessarily to attribute that. Okay, imagine that now you are going to write a book that is loosely based on the Divine Comedy or on the Iliad. Anybody there is that more or less can praise the origins back then, but you don't necessarily have to credit or pay to people that died centuries ago. But the public domain is basically something that happens really only after a certain amount of years after the death of the author. If by some accident you want to make that some piece of work, and normally this is applied to datasets, if you want that data, for example, it goes in the public domain, you use the CC0. Okay, and this makes it completely public domain. That's also, it's not required the crediting of the authorship. I think this probably used very little, but it's still a possibility, or at least it's important for you to understand how the copyright works. And remember that this 75 years or 20 years for patents is always a compromise, basically between, let's say, the state and the creators to say, okay, for a certain amount of years, you can be the only one making money with it, but then this goes to everybody. Okay, it's always like that. So if you go and see normally the definition, what you will see that basically the CC BY or an equivalent, which normally will tell you basically only the CC BY because there are very few other equivalent licensing, are the ones for being really open access. Okay, because the thing is that CC BY let you distribute the content, but also let other people, researchers, artists, whoever, to build on top of that. And again, and this is for further advancing knowledge. It's not just for distributing one article. So the perspective is different. Sometimes you find open access article that has other licenses. Please consider that they're not always considered fully as open access, and they have several other constraints. From also might be also for yourself. If you have an article that has non-commercial license on top of that, then you cannot even sell them. So it's not derivative. You cannot build on top of that. So normally, for again, let's see how much all these licenses are used. So normally the one that is used most is the CC BY. It's the simplest. It's really the one that is open access. So that's the main suggestion about all the definition and bodies working with open access. The non-conventional derivative is the second one, because this is, let's say, this is for whoever is not convinced about fully leaving the copyright scheme. This is the closest version. Another important thing, the Creative Commons license doesn't change or substitute the copyright. You know, it's always started on top of that. It's just another license for that says how everybody can use that content. So why open access is important now? So it's not just open access by itself, but it's part of a really big family or ecosystem of emerging approaches for sharing intellectual property, with mainly the focus on better developing them and exploiting them. Okay, so the real focus is not just on one single element, but how to create big ecosystem that can further develop them. Okay, and let's say that this probably can be traced back to two approaches. One started with open source software, the other one with open innovation. I'm putting them a bit separate because sometimes in literature you find an overlap, sometimes there is a bit different way for an IP. There's also, let's say, historical different origins. In open source software, which is also the one that basically created also the background and the context for the Creative Commons, this also removed from software to hardware, design, data, open content in general, creative. what is called open government is a bit more a mix of open data and other kind of processes, but it's a bit of idea of having more open practices in very broad fields and contexts. So it's not just one single thing, but it's part of a broad movement for the last 30, 40 years working on this. In terms of European projects and research, well, this is also part of another thing to be added, which is open science, but not only, and especially in terms of European projects, it's about this connection between these three approaches, which is open innovation, open science, open to the world. And you will find a description of this in the booklet that you can download from the European Commission. And this was actually also the result of the previous commissary working on this, Carlos Medas. But it's very good because it explains also in terms of what is the result from European research and why now open innovation, open science, and open to the world are really important for promoting research, both at the level of single individual researcher, but also at the level of Europe as a whole. So there are strategic reasons for doing this, not just for the promotion of your work. If you let people download your article, more people probably will read it. So it's better for you, but it's not just at the individual level. This is really at continent level. That's why this is really important. So these three elements, open innovation. So what's been happening, of course, that also the idea of open knowledge transfer has been developed further and further and expanded, not just enriching it, but also with the idea of moving forward and opening more and more the borders. Okay, so from outside in to couple inside out and having user and ecosystem. In terms of open science, and this is something that we'll see a bit later, this is another movement happening that actually is a way for opening up science with different approaches, as you see. So just from the data, the citizens involved in citizen science, more collaboration and promotion, that basically are creating a new way for doing science, and actually European Commission is committed to this. The third element, open to the world, this is very important because normally we tend to think still, or I'm from this country, so do research for this country, but this is not really happening anymore, especially in research. And what's happened that it's not just at single country level or European level, but of course we are part of the world. And through the years, as you see, things have been changed. Because if you see, this is the amount of budget spent on research. It's not the production, but it's basically how much of budget allocated. And for example, from the year 2000 to the year 2013, Europe went from 25.8 to 20.4. And the United States even lost more, and China rose more. Okay, so things have been changing. There is much more research done in other countries, mostly funding spent on research in other countries. So it's important also to collaborate with them, because it's not really meaningful to just do competition, and it's also important to acknowledge how much research is done in other places and work together with them. This is basically a share of highly cited scientific publications. And I'm sharing this because it's very good to show that, for example, EU as a whole is still the place with mostly highly scientific publication in the world, more than United States, more than China. This is something that normally we tend to overlook or not to think about it, because other countries, especially what we don't know, is always much more exotic, or we have more interest and we think that it's better. The grass of the neighbor is greener. So it's very good to consider this, that even through the years, this is kept as the first place. But again, still we are not the only one. And why don't we work together with the other ones? So also, why don't we work together not just on developing research, but also to translating it innovation in other countries, in other contexts, So something else that the Commission has been working for promoting this is, for example, the European Open Science Cloud. So this is a digital infrastructure for making open science. This has been developed by the European Commission. It's basically a mix of a world-class data infrastructure to store and manage data, and with high-speed connectivity to transport data and probably high-performance computers to process data. So depending on which kind of research you do, you might probably need this. You know, it's like sometimes some medical research or physics research will need that. But it's important because one thing is writing one paper on your own, and another thing is really working on massive data sets and massive projects. And the Commission has been working on having the infrastructure on this. And this is not just, you know, few single supercomputers and data centers that are able to few researchers, but it's an open science infrastructure. And this is mostly dedicated to data. It's for having access to data and building interoperable services. And also, this is also for promoting what is called fair data. And fair data is a set of principles for having data, for creating data sets for research. The FAIR is an acronym, means that these data sets should have availability, accessibility, interoperability, and reuse. This is actually the same approach that you will find in open access in an article or a paper, but applied to data sets. Okay, and again, it's important because you can let other people to work on that. For example, accessibility and interoperability, they will let people, you know, to mix this with other kind of data and build more research on top of that. Then this is more in general towards open access. It's Plan S, and based on Collection S. This has been an initiative that working on making open access a reality by this year, 2021. Okay, so it's already a few years that it's been working. It has worked on lobbying, on promotion, but also on creating tools for making this. It was quite strong initiative for promoting this. So there has been work also on making this much more possible, and you can find a lot of information there. One thing more that I will show you that is probably very small to see here, but if you see in the point one is basically say that this open access should be with Creative Commons attribution license. So it's CC BY. So again, to reiterate the principle, that is really one of the most important things. And this was backed by several universities and researchers, so it was, again, a public and open initiative. And among the tools that developed, for example, is this journal checker tool. And with this, you can check if, for example, a specific journal and whoever is funding you and your institution, they are complying with the Plan S. So do you want to know if you write for something for a journal within a European projects and working in one organization is really open access? This will give you the answer. So we will focus a bit more now on open science, DIY citizen science, right? Because it's a good way for understanding not just how to do open access in the specific, but how is this, you know, unfolding in research. You know, there are several trends that has been developing through the years. They're now more and more recognized, up to the point that these are actually part of strategies of the European Commission. So it's something that has to be considered now and the next years. So first, let's start with open science. So again, this is a movement. No, it's about making scientific research and its dissemination accessible to all levels. Okay, whoever in society, not necessarily be professional, but also amateur, just to make it as open as possible. And this means working on all the elements of scientific research, so publication, but also data, physical samples, software, and will add also hardware. You know, the idea of open science is to make it science transparent, accessible knowledge that is shared, developed through collaborative networks. This is again is also a mix of different things, from open data, open sources, open methodology, open peer review, open educational resources, and also open access. Yeah. We will see also this open peer review here further in the later. Is this element here? We will see also afterwards. So then what are DIY science and citizen science? And these are other trends that have been developing, and they are also connected to open science. these are elements that you can find also in open source software, so they are not coming completely out of the blue, but again, part of this big family and ecosystem of movement. A bit of the difference that DIY science, might be done by the scientists or people trained in research and so on, but sometimes they can be also outside of being affiliated to traditional academic institutions. And this might have also be the involvement of citizens, but normally this is about people who have more knowledge. Is of what is done with tools that are much more accessible now. Typically, these are more open source hardware and software. So it means that more research is happening also outside of specific affiliation or university organization. Citizen science means having an involvement of citizens also means citizens who are not trained in research to be part of the research process. Okay, and it could be in different parts, from analyzing data to collecting data, writing to a less extent, but it's still happening. Okay, normally it's about being collector of data, a resource provider, analyst, and in case stakeholder to be listened. Normally what happens in citizen science, you have people who are formally trained in researchers who organize the research. Okay, so you always have both professional and non-professional, just in a different way, Let's see some example. This is an example that will show you many different kinds of lecture because it's very interesting. This is a 3D printer. The 3D printer itself is quite simple. It's a 3D printer that uses a ray of light for solidifying resin. It's kind of stereolithography technology. What happened here, this was a biologist who also happened to be part of Hackerspace in London that modified the DNA of bacteria. I think it was Escherichia coli. In a way that if you put this bacteria inside an orange juice, and the orange juice is hit by a ray of light, the orange juice will solidify into plastic. Okay, and since the 3D printer print with a ray of light, basically with this, thanks to the bacteria, with the modified bacteria, you can 3D print in orange juice. What happened? This is not just somebody who was trained in science that then in the hackerspace developed this bacteria and explain, look, this is something that is totally feasible. Of course, you need knowledge and be trained for this, but even outside of a lab, you can do that. But he also shared all the documentation for modifying the bacteria. So you can also download it and do it somewhere else. And potentially this is very interesting because you don't need to have, oil-based plastics and resins for basically creating something. You can use an orange juice, tomato juice. It's not super clear in this picture. Of course, it was a first test, but what is printing, it's an H. So you can see here emerging the H from was the H of hackerspace. So I'm showing this because this is always an idea in the hacker maker movement to be able to produce things locally, but of course you always have some constraint. And this is, we have one person that is formally trained, but then one day went to an hackerspace and say, even outside of university, I can make this happen. Okay, so this is increasingly happening, whether we like it or not, and it's important to consider that it's a trend that we are working with. Citizen science can be of different types. Normally, they're about having the citizens are observers or collecting data. There is a full platform, a European project based on citizen science, which is this. I also put the screenshots of the drop-down if you want to look in the different categories. It's small now to see all the categories. The feature is quite small, but just to show, if you see it's a long list, means that the fields on which citizen science has been developed are really many ones. Okay, so it could be from agriculture to astronomy, biodiversity, biology, chemical sciences, food sciences, education, geography, even science policy and more. So if you've seen open science, it's really also about sharing everything that is done. So for example, imagine that you're developing a specific software for a research. well, you can document the software in the paper. We will see afterwards how to do it, how to cite it. But for example, there is a specific journal for only documenting the software itself. So you can have an article about the software itself and make it open. This is the journal of open source software. Now, what is happening now increasingly, more custom hardware, and especially open hardware, is developed for making scientific research. And this has been possible to several initiatives. Like the first one was the Arduino board. Now, Arduinos have many kind of electronic prototyping boards that can be used for creating different kind of projects, and then it inspired several other brands to have a different kind of boards with different technical features and so on. But basically made very simple to collect data, because it's easy to add sensors to these and collect the data and store it. But the way you create the hardware for collecting the data, of course, can change the results. So open hardware is becoming a reality also in research, because you should also document how to do that. Okay, so there is already a movement for open science hardware in different aspects. And there are also journals for documenting open hardware projects. So this Hardware X, for example, is published by the Elsevier. So as you see, this is already established. The last element of this again comes from the European Commission. And if you want, is based on an umbrella or brother sister elements of what is open source. Open source, of course, is giving access to the knowledge, but it's not only about that, it's about developing it in a collaborative way. So what is a bit missing in open science, that, okay, you're making available all the software, all the hardware, all the data, all the articles that you're doing. That doesn't mean that somebody will work on that. It's like you're leaving a wallet on the street, but if you do in the morning or in the afternoon or during the night, the results is going to be completely different. So the idea of RRI is basically, when research is planned, especially at the beginning, not at the end, of course, is to involve stakeholders into define that. Okay, what are the potential effects and impacts and also needs of a research, and especially of the society towards that. So there have been many RRI projects, and all focus on involving the citizens in a different way. I mean, citizen means any kind of stakeholders, could be also policymakers, could be normal citizen companies, because sometimes you have technologies that you need to understand as a whole to how to develop so that everybody can accept them. Okay, you see now, for example, how many people are still not accepting vaccination. This happened very fast, of course, because it's an emergency, but imagine that you can have the luxury of time for building a process where you have all, or most society, being engaged in discussing how to do that. Sometimes there are technologies that you need to do that. Sometimes, well, you don't have time, but if you can, that's a very good way of working with it. So the idea of RRI is about involving society in science and innovation, to align RRI with the values of society so that there is technological and political acceptance. It's a wide set of approaches for doing that. And in cases of cross-cutting issues for Horizon 2020 and for the European Commission. So it's so important that there is also a portal, these RRI tools, where you can find the European project, but also tools working on that. So it's about connecting policymakers, the education community, research community, business and industry, civil society organization. This is based on the idea of open access as well, public engagement, science education, ethics, gender equality, and governance. This is just very broadly. So open access is also part of RRI. So very briefly, personally, also been involved before joining RMIT in writing and a bit of running an RRI project. This is good. What was done here was to try to have, for example, science policy co-design between policymakers and citizens using co-creation labs, so as Fab Labs, science museums, and living labs. In RMIT Europe, this project Nano worked on defining future nanotechnologies through RRI. So you understand that this is also like nanotechnology, something you don't have a direct experience or perception. So how to make sure the citizen, understand something that is difficult to perceive with the normal eye, and see, how to shape it, So open access and open science. I will show you a very simple example, something that I did, but just to show you how it's possible to document everything. So this was many years ago, was already, 7 years ago. Together with other collaborators, we did an analysis of makers and makerspaces in Italy. Mostly what was happening in 2014, when the first labs were already a couple of years old, and try to understand again an ecosystem of creators working on open access as well, mostly in hardware, software, and design, how it was unfolding. So one important thing that back then, and this might happen to any other new phenomenon, when you start having a new thing, there was a lot of research done on this, but most of the time it wasn't really well developed. And in case you had several researchers, sometimes a lot of master students contacting a makerspace, asking always the same questions, up to the point that nobody wanted to reply all the time about that. So when we decided this together with all these makerspaces, we thought, okay, we are going to share everything so that if you need to do research on the topic, you can get what's already mapped in terms of data. And then if you really need to ask a question, you ask a different one. Like, don't call every day a lab asking how big is your space in terms of square meters, because it's not really their work to reply to that. So what we did, well, we created a report. This was in Italy, so the report was in Italian, but you can download it as open access. We did it as print on demand, so there is also a link if you want to have the paper version. So you can access it online. This is a simple thing, but for example, first we did also all the data sets for citing it, not just citation, but the BibTeX code. Again, this is another metadata that is important to have. Normal publisher do it. This is something that we did the website on our own. We also share all the data sets. We were anonymized, they were of course clean or whatever, but the data set itself was shared. And we also shared the questions for the survey. In this case, we use Lime Survey, which is an open source software for creating surveys. So we saved exported the files for doing the survey. In case you want to translate it, rerun it, change it. Hopefully we will do another version soon. And the idea is always documented so that anybody can do that. Actually, I think Sunday I got an email from Salvador. They were using this for accessing that and doing some analysis there. And also the software. There is a link here to where you can find the software that this is something that I did to analyze the survey and make the output of the charts that then we used. We also put a list of related publications, so you see whatever I think has been produced from that, between several articles. So in terms of software, because sometimes maybe you're not going to work with hardware, I don't know, but sometimes maybe you do some data analysis, and documenting even the software for doing that is very useful. One way, for example, is treat it as normally software is treated. For example, one, if now probably the most famous platform for doing that, is Github. You need to have some certain technical knowledge for working with that, but there is a lot of documentation on how to use that. But it's also where most of the open source developing is done. And you can also create your profile. So again, it's a promotion of the work you've been doing, and you can find through other researchers, not just developers, also what they've been doing. This is mine, for example. And normally every time I create software for a paper or an article, I also store it here. So this is, well, it's just a screenshot, but it's where I put all the files for analyzing the data for that research. In this case, I use Python. I normally use Python. And I use Jupyter Notebooks. It's a way for having in the browser and also for documenting. So it's also, you can also see in the preview there how this was done. So if you download this, it's basically everything is documented and saved in a way that you can redo this on the similar data set. If it's not the same, but you can redo everything from scratch. This is also about replicability of science. I will put an example, but it's something that increasingly we are debating. In some discipline, there is a crisis of replicability, so it's important to document as much as possible, so to be sure how it's done. So open access in Horizon 2020 and Horizon Europe projects. Okay, so I will show still Horizon 2020 because, well, we are both all projects still Horizon 2020. And in any case, Horizon Europe just started this year, but it's also building on top of that. As far as I know, there is no moving back. Actually, it's moving much more forward, as you will see later. So that's why it's important to work on that. So, and these are screenshots from the official documentation, okay, and official website. So first, of course, there is an explanation why it's important to have open access publication. So again, it's the idea of building on previous research results, encourage collaboration, speed up innovation, and involve citizens and society. Okay. There's a lot of information. What I would like to show you see the last part is, let's say, that basically under Horizon 2020, the legal basis for open access is laid down in the framework program and its rules for participation. So this is formally written. It's not just a broad suggestion. And these are translated into specific requirements in the grant agreement for the project. So it's fully formalized. Especially this is Article 29.2 of the grant agreement that require under Horizon 2020 that each beneficiary must ensure open access to all peer-reviewed scientific publications relating to its results. Again, open access can be to a lot of different things. So in the context of European projects about peer-reviewed scientific publications, it could be to many more things, and you can do it, many more things, but at least for all peer-reviewed scientific publications, this should be done, okay? So in this case, it's not just article, it's article, yes, but also about research data. Okay, these are the two main elements that there is focus on. Again, if you have something else, a presentation, a video, a poster, something else that is not a peer review publication that can be stored, is perfect. But at least peer review publication, scientific publication, and research data. As you see, they also make clear, you know what, this open access, oh, we have the Budapest Declaration and the Berlin Declaration. Okay, so that's why these are two important declarations. There are two ways in Horizon 2020 for having open access. So the gold open access, this will include also the diamond open access, okay? Because diamond, remember, is basically diamond and gold, the only difference that there is no funding paid for that. And the other one is the self-archiving / the green open access, okay? So sometimes you see, okay, you have some funding European project, but it's limited, of course, so you cannot publish 10 or 20 or more article if the Apc fees are 2,000 or 3,000 or 9,000 euro. You know, you will drain all the budget in a blink of an eye. So there is no excuse to, oh no, I don't have all the budget in the world, because also green open access is acceptable by the Commission. It's not as good as gold open access, neither for you, neither for the project, neither for Europe. That's important to consider, but it's still something that is acceptable. Okay. Sometimes you will have to wait for a period of time, which is called an embargo. That depends on the publisher. Normally it's a year, could be 2 years. It depends on the publisher. Check it. After that, you can do it. But sometimes there is no embargo at all, so you can share the preprint as soon as possible. Again, it depends on the publisher. Best thing again is gold or diamond. So it's important again to consider also data, you know, to share this also data, okay? This says more or less the same thing about letting people able to access it, and it's part of research. But as you see, there is a section about data self. That's why I put this, just to show, okay, this is as important as the other one. This again comes from the documentation. It's an important thing because basically says, well, you're doing research. Okay, so you have a dissemination plan on how to do the research. This is at European project level, okay, and the data management plan. Now, the starting point for you to consider open access, let's say it could be even before, it should be in the dissemination plan and in data management plan. But the real decision is when you decide, should I disseminate or share the results? So the thing is, if you want to disseminate and share the results, then they have to be open access. Okay? If you don't want to share, fine. You don't have to share. But if you do share, if you put things out online, then they have to be open access. So publication has to be either gold, diamond, or green. Research data should be basically access to use free of charge. Be careful about restricted access. That's something that is very important to understand. What happens if you have some data that is not anonymized? Well, before sharing, you anonymize it or you make sure that it can be shared. This goes before open access. Okay, it's something that you can share. On the other side, if there is something that research results that you want to exploit commercially, /protect, keep it as a secret, then you have patenting or other photo protection. Okay, you can go on that way. The difference is, again, if you decide to disseminate and share, then it must be open. So this is also one of the moments where you have to decide in a European project how to move forward. You will see there is also much more documentation in details about how to do this. You know, how to do the gold open access or green open access. I will skip it, but just to show that everything is well detailed. This is a part about the green and gold. So cost of Apc fees, as I said before, you know, the funding, even if generous, is not always limited. So cost of an Apc fee can come from the project budget, but it depends on the amount available. Okay, so the number of paid Apc might vary depending on each project budget. Green open access is always a free option and it's free, so it doesn't cost to do green open access. And not all open access charge Apc fees. Okay, so if you have the option for a platinum diamond, it's the best option for everybody, for you, for the project, for them. You know, so now, since basically most of Horizon 2020 is done, not all of it because we are still in it, but we already have some results from it. And basically 81% of Horizon 2020 papers were published in open access. So as you see, it's not just it's mandatory, but it's a good thing. The other thing is basically, I think that it was 56% of these were published in open access journal. The other one were in a paywall hybrid format. So still basically the majority of open access on Horizon 2020 took place really in completely open access. This big majority. Always following this principle, this is based on this dataset released by the Commission, so you can also go and check into details how the results are in terms of open access in Horizon 2020. And this is probably something that is not going to concern you, but it's also always useful to see, to understand how this happens, maybe in the future, but in case also to understand how it is managed. In the funding and tenders portal, where the European projects are managed, there is a section for that. So there is a part called continuous reporting. It's basically the project is always documented. And there is a section in it called publications. Then you have a field for each article, where you can fill the information of an article. Then there is in each field a specific section about this article, this book, this conference paper. What's it? Is it green open access, gold open access? No. If there is an embargo, how many months? Is this peer reviewed? Is it a joint and private publication? As you see, all of these are compulsory. If you put gold open access, also the amount of money spent on that can be documented. This is very important for the Commission to understand how much money is allocated to this. So for example, if it's a diamond open access, it's 0. What happens when you say, no, this is not open access? Well, the portal will not let you add it and will remind you that section 29.2 of the grant agreement, make sure that all the peer-reviewed results should be open access. So it's a very important reminder. You cannot escape that. So Horizon Europe. Okay, so as you probably already know, these are what are called FPs, or basically framework program. This is how they advance research and innovation in European Union. These already been several iterations. This is actually will be the 9, because before Horizon 2020 was FP7, so Horizon 2020 should be FP8. Then they thought maybe we can use a different brand, something that it's easier for people to understand. So Horizon Europe is then will be FP9. Now the last 7 years, before it was a bit less at the beginning. And again, this is different, but it's an evolution of Horizon 2020. It's not probably as big as a change as Horizon 2020 was. Few things that are as a different that we can already say that stands out. First is the European Innovation Council. So as you remember, one of the charts before, it says Europe as basically the biggest share of highly cited publication. So as a whole, we are, let's say, the best one in terms of highly cited publication. In terms of developing research, then there is a bit of a problem. There is always a big gap between doing research and then translating it into innovation, into something that is tangible to everybody. It depends on the context, independent research, but there is always a gap. Like, not all research is transformed into something that people can access to. Okay, and it's not just in terms of how many papers can be accessed. It's like if this paper, is about a new product, a new service, can I, as a citizen, really access and do that? Okay, and for example, United States do that much better. We are behind that, so that's why now the European Commission launched the European Innovation Council, which is a specific body for what's that. And this is really important part. Open Inno Train is basically studying this. How to make sure that research is related is constantly accessible, how to make it at a big scale, so how to make it possible that we are not losing all that precious knowledge that we have been developing. Another important element of Horizon Europe is that it's mission-oriented, so all the projects are built around a specific set of missions. Missions are, let's say, quite broad and understandable topics, like, I don't know, like fighting cancer. And then all the projects, they address a specific elements, but this is also a way for making clear to everybody what are we working for. Sometimes you can say, well, I'm working on this project with this code, this grant agreement number, but it's very complex and not understandable. But then if you say, okay, I'm actually contributing for fighting cancer or for preserving biodiversity, that is something that everybody will understand. As you see here, I see something that say open science policy, mandatory open access to publication and open science principles are applied throughout the program. So while before it was something experimental, that then become more and more, and now it's really mandatory. Okay, so that's why I'm showing this. So before it was a bit of experimentation, now it's really part of it. There is also a leaflet, for example, of Horizon Europe. As you see, we have Maria Gabriel, which is the commissioner, and this is really about what is open science. It's something very simple. It's a leaflet, so you can also use for not just reading it, but for explaining and promoting what is open science. And there are several elements of Horizon Europe that works on that. So the research infrastructure part, including the Open Science Cloud, but not only, it's a big part of that. Okay, so again, this is working at scale means we need an infrastructure. As you see, the second element is that Marie Sklodowska-Curie Action, they specifically work on that. Okay, so we also have a specific push to work on that. And something else also in the widening participation, that means it's a connection between some different countries in Europe. There is something else that will also a bit further in the details, which is Open Research Europe Publishing Platform. Basically, the European Commission created a diamond, platinum journal for having open access. And then there is a further focus on key impact pathways, okay, and about how to have the impact of a program level. And one is basically really about open science, you know, it's about fostering diffusion of knowledge on open science. So Open Research Europe, okay, so as we saw, like the great majority of results from Horizon 2020 were open access, but, you know, imagine when you count thousands of projects, you know, hundreds of projects and all the Apc fees, you understand it's a big part of the budget that, you know, is public budget going to develop research that then is basically private to private just to host the documentation and having that, okay? Sometimes it works, sometimes you understand that that's big limitation what can be done. So what the Commission did is basically created a specific journal called Open Research Europe, okay? This is an open access publishing platform. This is dedicated to a European project, so only to Horizon 2020 and Horizon Europe projects. There is no cost for that. This is also very quick, and it's all documented, there's all the metadata, and also has an open peer review. That was one of the elements of open science that we saw before. It's also that. So why does it fit here? You know, you see the evolution of in the FPs. You know, in FP7 there were some pilots, okay, about the possibility of open access. Then it was made a bit more mandatory, and in Horizon 2020, in the first stage, there was some piloting. Then it became a bit more by default, and now everything is basically by default. So it's part of an evolution, you know, and this is now really part of it. So that's why now you have this journal. You can still publish somewhere else, just, you know, that has to be open access, and of course there is no excuse to, oh, there is no funding for that because the Commission is providing this. This is a bit of the process. So when you submit it, the preprint, there is that version, it's already accessible. So it's not just it's open access in terms of the license when it's over, all the process is openly accessible and documented. The reviews are documented and each version is documented. So you know what the reviewers done. So everything is really done with an open science approach. Of course, there is still some money to be spent in managing this publication. Again, it's not just about putting a file online, but, you know, managing all the process. More precisely, each article costs to the Commission, because is the Commission pay for this? It's cost 780 euro. And then you can go on the website and see how much this money is spent in all the activities of the platform. The platform was, well, done by the Commission and basically, you know, open with a bid. So it's a private doing for the Commission. So the contract is accessible. So you can see all the budget and how all of this is documented. So all of it is very transparent again with the following the principle of open access. So this is an example of an article. Things that are interesting that you already see, this is a version 4, it's been reviewed and 4 approved. And you can see all the different versions here on the right and how it was done. So again, you can see also how the development of the article went through and how it was criticized, improved, and so on. So you can also learn from that. If you want to see how this review in an article like this is done, you can also see that. So finally, some example, platform tools, best practice, some more practical things. This is a short and nice book from MIT Press about open access. And this is actually open access itself, so you can read it online. Okay, so this is also a bit more of explanation about what is open access, also beside the specific Budapest and Berlin definition. When you don't know which license to use, especially in terms of open source license, and this means also about software, there is this website, choosealicense.com, and it works in a non-technical way, meaning that it gives you some option. It will ask you what would you like to do, and then based on what you would like to do, we'll suggest you one or more licenses. So this is a non-technical, non-legal way for understanding more about open source licenses. And this, for example, is important Also for the license for the software that you release with the paper, you want to decide which specific license. Because again, if you don't specify a license, it's copyright, so nobody can share it. And then it depends on organization. Of course, each organization has a different perspective. I remember this when I was a student at Alto. It did, of course, change, but sometimes some organizations have some specific agreements with some specific publishers. This changes through time, depends on the organization. Sometimes a university might have fundings in general for open access. Sometimes it might be that since they have to pay for having access to this journal, and they get some extra discount. Yes, because it happens that then university have to pay for having access to the paper that we're developing in the university. That's also why sometimes it's criticized. So checking your organization, depending on which one, they might have something. In this case, I remember that there were some discount and there was a specific period of time, and there is something specific. So it's not always straightforward, but there might be also this as an option. In terms of RRI, there is this database, RRI tools, which doesn't just explain the concept, but that basically all the projects about RRI listed, but also all the different kind of tools, toolkits, papers, books, reports about all these topics. It's a very good starting point if you want to understand more, because you can really tailor the research on context. And this is OpenAIRE. It's a platform also from the Commission. This was, I think it was on a Horizon 2020 project. It's more technical, but I can share a bit just to explain a bit how it works. It's basically all the open access thing of a project, of European projects, and not only for European projects, are stored here. And these are all these data interoperability, technical features to make really open access, not just the download of an article, but really a platform that can be used for building research. So it tends to align also policies with stakeholders with that. It's general through the providing open science services, linking research and monitoring, as some training too, and for facilities, well, the services for building collaboration, community, global bridges. So this is, as you see, is connected with the European Open Science Cloud. So this is about interoperability. This is why having all this as open data with research data connected is make easier also to having all these platform and service to talk together. You have a list of article feature resources that you can browse. And you can find a page for each European project too. So in this case, there's one with opening a train. You can check how it's gone, how it's developed, how many publications, and so forth. Now, what's happened? And once you have article in OpenAIRE, for example, as an opening a train, then automatically they show up in the European portal, in the funding and tenders portal. These are all connected. Okay, so this exactly there is a section. This is a bit small, but basically say suggested publication from OpenAIRE. Okay, so again, also the funding and tender portal is connected to this. So you realize that this is really about creating a digital economy for research. So OpenAIRE also sections for giving an overview about all the data. So you understand how many, for example, journals there are, literature repositories, data repositories. So I connected also other things, so you can see all the open access ecosystem through this. There is a section also for building community for working with other researchers, sometimes on specific topic. I think there is one on coronavirus, for example. So for gathering research together and making it easier to access it and work together. So you see this one. So this has how many? 1,000, almost 100,000, 170,000 articles, I think. So then you can also check the European Commission, but not only, you also have different countries, also non-EU countries. And you can see the number of projects and number of organizations, countries. You get some of this data from the European Commission itself, but here you see how it's connected with open science and open access. So you see this, we're already talking about 61,000 projects. So this is really where you perceive the scale of the impact of research. And for example, you see projects in the countries, type of projects, which are the countries that are more involved, and which are the organization. You can see also how much of it was done as open access. This bar chart at the bottom, you see also the evolution of open access through the years. For example, I think that the red bar is about proprietary access, so it's not open access, and it's also decreasing through the years. And it's the one small one is decreasing. The other one that you see, I think, is hybrid, is something else. So you can also monitor how this has been developing through the years. Another platform that is connected to this is Zenodo. Zenodo is also open source. I mean, you can access the code itself. And Zenodo is hosted at CERN, the Large Hadron Collider. So Zenodo is basically it's a repository for articles, datasets, presentations, videos, poster. Anything you can produce can be stored on Zenodo. So Zenodo is hosted by CERN, means they really have a big data infrastructure. So Zenodo is for free, and you can be sure that CERN is gonna live for a while. Okay, Zenodo does several things. Provide a DOI, a digital object identifier, for any kind of item you store there. So software, dataset, a PowerPoint presentation, a deliverable, any of this. And it's also connected directly through OpenAIRE and through OpenAIRE to the funding and tenders portal. So an easy way to access OpenAIRE is through Zenodo. Zenodo also has public pages, so you can find the information there. And again, since everything is open access, it can be shared. It can be moved from one to another. So for example, if an article that's about open access can be there, you have all the information, you have more statistics. For example, OpenInnoTrain has a specific section. I think also created one for Einstein, where you can see all the publications that are open access. And how does it work? You go to an upload. It's important that, of course, you have to upload some files. Otherwise, there is no point of storing it. So until you don't upload a file, you can save it as a draft, but then you're not able to publish. So you can add any file as possible. And then you can choose what is it. If it's a publication, it's a poster, presentation, data, video, software, you have many things. Okay? So the type of different things can be done, choose a lot. You can choose also which kind of projects this is part of. This is good. Then you can add, well, all the details, the titles, the author. For each author, you have to add the ORCID ID. Okay, this is something else that is very useful because then it's connected to your ID. As you see, you have a section about if it's open access, what kind of access. This is one of the places, for example, that if you don't put Creative Commons attribution, it will tell you, okay, this is not open access. It's another kind of access. So it's very strict, but you saw that's what the definition is. So that's very important. Then you have a section about funding, and you can put the name of the project or the ID, the grant number of a project, and it will find the project itself. So for example, in this case, I tried OpenInnoTrain. So this again is also for OpenAIRE, for categorizing in OpenAIRE and then reporting to the commission. You can also add a software, and you can get a DOI of a specific version of a software that you use and then cite in the paper. I did that, for a specific paper. I say, okay, use this version. I knew that, in the future I would have improved that, so that's why I created a DOI for that. So if you want to know what I did, and maybe find even a bug, a mistake in that, you can go and check that specific version, not just the software in general. And this is connected automatically to Github. So if you log in with that, you connect and you put on as an option. Every time you create a new release on Github, you will find over there that this is stored and as a DOI. So it stores also if you lose the repository in Github, the version is always there, and you have a DOI for citing it. So in this case, this is just an example. I did an analysis of data on GitHub. So I created a software in Python for analyzing interactions in GitHub. And I released this as a Python module, so you can reuse in any kind of Python projects. So the version I use for a paper for a specific conference is stored on Zenodo, and I have the DOI for that. So that's cited also. It was cited also, I think, in the final version of the paper, in the camera ready version. The data set I created for the paper, and then if you read the paper, you will see a visualization of that are also stored. And also you will get a DOI for this as well, which is also good, again, for citing it. And the paper itself is on open access, so then afterwards I also store the paper. Okay, so you have everything also there. Well, that was it in terms of slides. I think it probably is the moment if you have questions, a lot of questions. It's for you. Thank you.